Hello, Trevon. I am responding to your paper 2, United States Water versus Energy Crisis. With the growing population of our nation, the demand for clean water has grown to an all-time high. But this growing population is associated with more trash, pollution, and other waste being accumulated on streets and sewers. Much of the water that is recycled and turned to drinking water is heavily contaminated. Almost all of the water that flows, from the homes to the sewage plant is a disgusting mix of detergents, pharmaceuticals, leftovers, and of course bodily waste. Ew. For people who have safe and drinkable water, there needs to be technology to separate these contaminants from the water, because without filtration, this water is deadly. With this controversy comes the idea of how precise we want our standards on drinking water quality. Is having good drinking water going to be safe enough, or do we need to use stronger machinery to get perfectly drinkable water with little to no contaminants? The most common answer would be to use stronger machinery to create best quality, but this fails to realize the extensive amount of energy that goes into operating these machines. These controversies go hand in hand, one side being how water quality is highest with better machinery, but the machinery requires ample amounts of energy and money in the grand scheme of things. I can see why you would want one more sentence after operating these machines, that last sentence there, but I don't feel like that last sentence really adds to what you have to say, maybe. And I think, maybe you'll go into this, but I feel like, what did you use for this distinction? You used perfectly drinkable. Maybe you ran across this in your research. I know there are words that people use for this issue of there's water that's safe to bathe in, there's water that's safe to drink, there's water that doesn't have any contaminants, which I think actually at some point might become problematic even. I want there to be fluoride in the water because it helps my teeth. But anyway, maybe you'll figure that out here. I think that trying to sort out what levels you're talking about, right? Because I don't think you're saying that we should ever have water that you can't, that'll make you sick or something. But yeah, okay. Why am I talking so much about that? The water filtration companies are those that have the most power in controlling the water quality in the United States. The statistics that are coming from these companies are not intriguing, as the water supply are not intriguing as the water supplies are dropping dramatically on a global scale. Wait, they're not intriguing? That sounds intriguing. Probably a typo. From their data, we can see that the available amount of water dropped from 17,000 cubic meters per person in 1950 to 7,000 cubic meters per person in 2000. Oh boy. This major decrease in the 50 years is alarming because of events like water stress and a water crisis that occurs when water levels drop between 1,700 and 1,000 cubic meters per person. This problem has become a reality for countries like Qatar, Libya, and Israel, whose water levels are far below 400 cubic meters per person. With 80% of the world's experiencing a threat to their water supplies With 80% of the world experiencing a threat to their water supplies, maybe this reveals or something. A little fix there. The relevance of water supply and water quality issues for us in the United States. That's crazy. I've been to Qatar freakishly. And yeah, it's very, 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 very dry there, but I'm worried, and all I can tell you is I've only lived in places with plenty of water nearby. And I'm a vegetarian. So I save everybody water. Water and energy are used together in a multitude of industrial applications in the United States, and it's projected that energy consumption will increase by 50% by 2030. Whoa, globally. Sheesh. Although the statistic is on a global scale, we can use to predict that the United States energy consumption, so you want an apostrophe after the S, because the energy consumption belongs to the United States. Yeah, that's a really tricky one. Okay, well, increase by a moderate percentage, I think you want to say, as well. The controversy here is that as energy levels increase, the water levels should increase in correlation with them. This is because of their connected uses like hydroelectric energy, which contributes immensely to our total energy creation. But as we can see from the previous paragraph, the water levels are trending in the opposite direction. For instance, if we look at places like the California Aqueduct, Moss Landing Power Station in Monterey Bay, Wattapam Dam, and Hoover Dam, water movement is vital to creating energy, and without this water being moved through various canals and streams, no energy is being created. Yep, this is the main reason that states like California are facing major droughts and water shortages, because of them not having enough water. That's not enough is being accumulated through the energy plants that can be used to create energy. Oh, snap. That's bad. Whew, okay. There have been many groups and researchers, and you're doing well. That's why I'm only reacting to your ideas mostly and not your writing. That's exactly what we want. There have been many groups and researchers that have tried to crack the code on how to make energy use more efficient how to make energy use more efficient based on the sparse amounts of water that are available. The University of Iowa Institute of Hydraulic Research has been working through this dilemma since 1920. What makes the research unique compared to other groups that are studying this problem is the inclusion of studying salmon to see how water flow works. Okay, I was going to say, where's your source? There it is. For thousands of years, salmon have swum upstream from the Pacific Ocean, habitats to the Pacific Northwest, where the waters are more shallow and can lay their eggs. These eggs then hatch and float downstream to the Pacific Ocean, where they grow up and the process is restarted with another group of salmon. How the salmon were able to swim upstream to lay their eggs was an intriguing idea to the University of Iowa researchers in ways that water could do the same and lead to less infrastructure having to be built to make the water flow downstream. What? In ways that the water could do the same and lead to less infrastructure having to be built to make the water. I think that could be clearer. I'm not quite sure I know what you mean. Water doesn't have the same physical structure as salmon, like strong fins and gills, but there can be machinery that can help water institute a similar way of movement. This process is all part of fluid engineering, and this is a very specific type of mechanical engineering. Through many of the principles of engineering, the group was able to make a small-scale model of a hydropower turbine to help water travel upstream, just like the salmon do to lay their eggs. Oh, what? That's crazy. This technology can be explained as a wind turbine in the water to regulate water flow. Like, why do we want it to go up there? Because there's not enough water at the other end, but that's where the water's coming from? I guess it's from another tributary or something. Okay, this technique is relevant to this issue because any way that energy, space, and water can be more efficiently used, the better for the outcome of cleaner water. Small thing, your anyway should be two separate words. It's one word when you say, oh, I was going to do that anyway. And it's two words when you say, is there any way we can solve this problem? Shifting gears to how all this ties together, the ultimate goal, sorry, time check, we're good. The ultimate goal is to try and have energy and water levels in proportion to each other so they can be used interchangeably when need be. But we can see from the beginning paragraphs, that water supplies are depleting with no solutions, and to make efficient use of the water that we do have requires special machinery, meaning more money and energy. So I think in an academic paper, people sometimes use phrases like as previously stated or as has already been shown or something like that, rather than from the beginning paragraphs. Like, I mean, there's no reason we do it that way, but I think that would fit better. Okay, the answer, leading all back to the original controversy, how do we use the energy that we have left to clean water that is getting as dirtier as time goes on without breaking the bank? I'm really getting worried here, Trevon. I hope you're going to resolve this. Okay. The answer to this is all still very far away, which is the reason why this is such a big controversy in the mechanical engineering field. Kevin M. Morlanges wrote a very interesting article on how the problem can begin to get solved. It all started with standards. We can think of our water issue in the United States as a city that just went through a catastrophic event like a hurricane. Many people in a hurricane are left with almost nothing as their homes and belongings are destroyed. But they still need necessities like water and food. So when they need water, there's plenty of water around them, but it's all dirty. So they just need any type of clean water, even if it's not the cleanest water. Right? In our situation, we must set a standard of having clean water and not the cleanest water, just like in the hurricane analogy. Love it. This may sound bad or nasty, not to me, because my standards are low, but we must be realistic for the resources that we do have left. Sorry. As previously explained, water demand is at an all-time high, but we have a little water to begin with. I don't think you quite mean to begin with. I just said, but we have water shortages or something like that. Because to begin with just makes me think we're like looking back to the past, and you don't mean the past, you mean like now. That water is only becoming more contaminated, and the energy that can be used to generate more water or clean the water can't be generated naturally because of the high amount that's needed, and it's not cost effective enough to put it towards heavy machinery. The other thing that I'm wondering then is that, like, for the energy to deal with the water, I mean, there's a lot of other sources we could get that from, right? I don't know if you're going to talk about that, but Like, we could build a bunch of nuclear power plants and they could all help us get that power, right? Or we could build a bunch of coal power plants for that matter, although I don't think anyone wants to do that. Okay, by analyzing the multifaceted controversy, we can see that the energy and water companies are in power and they are trying to determine which values are the most ethical but cost efficient at the same time. This is a common controversy of health versus wealth. Yep, the water filtration companies are trying to make the healthiest water they can with the given circumstances while still using their money in the best way, I think it might be missing there. The best possible way or something like that. And not wasting on resources or machines that aren't an absolute necessity. This also brings in the value of meaningful work because everything needs a purpose here. Any amount of energy wasted is a waste of money, and an ounce of water that is not clean enough could cause major health risks for those who are drinking it. Yep. There are obvious conflicts in these values as most conflicts boil down to money and resources. The water filtration companies must hold up to getting clean water, must hold up their responsibility or something. A little revision there. But it's very hard to do this when the odds are stacked against them and they have no choice but to lower standards or use better machinery and lose money. Thinking of this issue long term, losing money isn't an option because if these companies continue to lose money, they will eventually go bankrupt and there will be no more filtration plants. So are these privately owned places? You've gone into such wonderful and technical details here that's definitely what I'm wondering. Are all of them privately owned or some of them owned by the cities themselves? I kind of thought they were, but I could definitely be wrong. So as of now, it seems like the best option is to lower the standards of water quality and just hope that the contamination levels don't get so bad that the machinery that is already there will not get the job done. This is a very tough decision to make, but until a better system can be created or water supply levels increase, this is the only viable option. Along with this being the only viable option, given the rough circumstances, I still feel like it benefits both the filtration plants and the people. In hindsight, we don't know what is in everything that we eat or drink daily. But with that being said, almost all of what we consume is clean enough to keep us healthy and alive. So we must take that approach to our water crisis as we may not know all of what is in it, but we know that if there are contaminants, they are so small that it isn't even noticeable. That's a very good point. And I think a lot of these environmental discussions, sorry, time check, we're good, do come down to that. That's something that I often stop and ask myself. Like, our bodies are designed to deal with things that aren't, with an imperfect world. We're not designed to live in a sanitized bubble at all. But yeah, figuring out like how much can your body deal with and still be okay is the tricky thing, right? Because some of these, especially new things that we've created, new chemicals, like, can be hard to know how much people's bodies can take. I also like to throw in, just because I'm like that, like, I mean, we're all gonna die anyway, which may sound terrible, but I mean, it's true. And when you're thinking about those costs and benefits, I mean, that's a part of the equation in the very big picture. I mean, yeah, it does sound crazy, but I guess like in terms of, you really do have to keep your eye on who will this hurt and how much will it hurt them? What are the odds of it hurting them, right? And if I had this bottle of water to give my 105-year-old grandma, I wouldn't really be too worried about if there was something weird in it, because, God, this is taking a strange turn, Trevon. I'm sorry. The other way I think we can generate more options by solving this problem is by creating more pull for this topic in the political world. Within politics, the stance of elected officials include an environmental stance, but that doesn't put the water crisis at the top of its list for solving these environmental problems. Things like climate change are mostly what is talked about when these environmental stances are brought up. The water and energy crisis in our nation needs to be right with that because it has just as much of an impact, if not more, if it isn't taken care of properly. We're bringing a water issue into the political realm. I lost my place. It will allow voters to see what is going on, let them know that they too need to make an effort to do better with putting trash in the right places and not wasting water. The only way to make this problem better is to work better with the resources that we do have and to brainstorm ideas on long-term solutions as a whole. The water crisis is something I grew up hearing about with third world countries and those that are less fortunate, but after looking at this topic, we have a water crisis of our own in the United States. The worst thing about our crisis is that we still don't have a solution to this problem because it needs a long-term solution. The only solution can be developed at this point or short-term because of limited money and supplies. One of the reasons I entered this field and it intrigues me is because the real-world applications and problems that it can solve, just like the University of Iowa engineers who are mentioned, and multitude of other scientists are involved in the controversy. We must put this water issue at the forefront of our national agenda. Okay, because we're almost out of time, I'm going to be like, awesome paper! Thank you!